Hello and welcome to my exam mini video 6 on the Thorney Dragon Development Network via the magnificent Desert Thorney Dragons. So today we're going to be going through this hypothetical developmental network of spike, as you see here. This network of the genome sequence allows us to see if there will be a formation of spikes or not, based on where the arrows are and the T-bars are. The T-bars stand for the blocking transcription and the arrows stand for activation of transcription. So we're going to take a look at 5 different strains of the identical developmental networks that we see here in the Thorney Dragon's nest. And fun fact, they do actually lay eggs. Our first strain is the wild type, which is basically the original. Everything stays as is. So S activates P, which then blocks I, which then allows K to activate E, which activates spikes in this strain. Next is the removal of P. With P gone, I then blocks K, who then can't activate E, who isn't activated either because of this, so no spikes are formed. Then, when I is removed, K now gets to stay activated with I no longer blocking it. So then E gets activated, which also activates the formation of spikes. As we continue, we have the strain with the double removal of I and E. The main focus here is that E is removed. So no matter what happens before E, E is not activated, so there will be no formation of spikes. Lastly, in another double removal strain of S and K, we see that nothing is activated with K removed. There is nothing to activate E, so there is no spikes formed from our last strain of our identical developmental networks. After going through all the strains, that leads us to this question. Why is it that all our eggs have the same genome sequences, but not all the Thorney dragons have spikes? One hypothesis and explanation of this is alternative splicing. Alternative splicing is the process where the same developmental networks or one pre-mRNA can be spliced into more than one different mRNAs, which produce different amino acid sequences, which then goes to produce variations or different presences of a phenotype, such as having spikes or not. This removes and literally splices off different introns and or extrons for different quote-unquote combinations or strains, as we experimented with earlier and as seen in this diagram to the right of the screen. Thank you so much for watching.